All right, so today's lesson is on solving radical equations. Our strategy, for the most part, is to isolate the radical part and then undo it. And understanding the inverse of square root is squaring. The inverse of cube root is cubing. It's the power and the index that are inverses of each other. So if I want to undo a square root, what do? You square it. If I want to undo a cube root, what do? I cube it, right? The power and the index undo each other. But at the end of the question, and sometimes in the middle of it you can tell this, there are solutions that are extraneous. Remember what that meant if you had an extraneous solution? So an extraneous solution means it's a solution that makes the original equation undefined, right? So you did the work correctly, but when you put it back in the equation to check if you did it right or not, in this situation it would make it imaginary. So why would that be for a radical? And this is important to remember, that even roots, square root, fourth root, sixth root, even roots, can you have a negative underneath there? It's imaginary. That's what creates it. If it's a cube root, all numbers are good. So odd roots, all numbers are good. Even roots, we have to make sure that it's not extraneous. All right. Let's look at number one. How would I solve it? So first, recognize the radical part. That's the square root of x. How can I isolate that to solve it? So beside it is adding 5. So subtract 5 to both sides. 12 take away 5 is 7. And now here's that step. How do I undo a square root? What do I do to both sides? I square it. So the square root and the square undo each other. It's just x. And 7 squared is 49. Take that answer, 49. If I put it back into the equation, does it solve the equation? For a radical equation, we have to do that extra step at the end to make sure the solution is not extraneous. Number 2. Do you see the radical part? I want to isolate it. So what can I do to get the radical part by itself? So you could do this in 2 steps or 1 step. So I'd rather do it in 1 step. So you know what I'm going to do in 1 step? Is I'm going to add the fourth root of m to the right side. Do you see how it's subtracting? I added it to the right side, and now it's isolated. What exponent undoes the fourth root? And it's the power of 4. That leaves me just with m, and 3 to the exponent 4. 3 times 3 times 3 times 3 is 81. Can we check to make sure that it actually works? So take your answer, plug it back in. The fourth root of 81 is 3, and 3 take away 3 is 0, so it's a good answer. Number 3. I want you to recognize the radical part. And recognize what's outside of the radical part that I can undo to solve it. So the inverse of adding 10 is 2. Subtract 10. So we have the square root of 8 plus 7 is equal to 1. How do I undo a square root? Is to square both sides. So that's 8 plus 7 is equal to 1. And then subtract 7. And the answer is negative 6. Just because the answer is negative doesn't mean it doesn't work. I have to plug it in and see if it gives me a negative number under the square root sign. So I take this answer, I go back to the beginning. Where there's an A, put in negative 6, and check to make sure it's a good solution. So negative 6 plus 7 is 1. The square root of 1 is 1. And you can tell that that solution works for that equation. Number 4. Step number 1. Are we ready now to help me? Kaylin, what should I do first? If I subtract 10 to both sides, what am I left with on the left side? And what do I have on the right side? How do you undo a square root? And then what do you get? Then what would you do? Does 6 go into 54 evenly? How many times? So I want to take this answer and I want to see if it actually works. So if I go back to the equation and plug that in, right? 6 times 9 is 54. 54 take away 5 is 49. What do you see is happening here? The square root of 49 is 7. Clearly something bad, right? 7 plus 10 is not 3. Did that solution work? So, in this situation, 9 is not an answer. There is no solution here. And I purposely went past the point that I would normally go past. There is a point in the equation I should have stopped, and it was over. Do you know where it was? And I didn't have to do all of that? Do you see that we had the square root of 6w subtract 5 equaling to negative 7? Can you take the square root of any number and the answer could ever be negative? So when you isolate the square root and it's equal to a negative number, at this point I knew there was no solution. Because there's no way the square root of something could equal negative 7. It's over. But I wanted to show you that you could do the work right and it still wouldn't work out at the end. So what name do we call 9? We call it a solution, right? So in this one, we have no other one to go by. So the only solution that we have, and then you know the ones that love drawing a line through their circle? You know those people? You get to do that for this one. Draw a circle and put a line through it. Because that's what it means. No solution. All right, let's try number 5. One step at a time. All right, Clarissa, what should I do first? And if you want support, I'd give it to you. I'd love to. I want you to recognize the radical part. What's the radical part of the equation? Could you identify it? Or you could say, I don't see it. A radical is also the same as a fractional exponent. Do you see a fraction exponent in the equation? And the base touching the fractional exponent, this, what I circled, is the radical part. So first step is, can you identify the radical part? I understand what you're doing. I'll give you a second. Tell me, give me a nod when you're ready. Okay, what should you do next? No, I can keep it as an exponent, but instead, is there anything in front or behind it? Is there anything outside the parentheses that I can undo? What is it? So how do I undo it? By negative 9. So negative 36 divided by negative 9 is 4. And I have c subtract 12 to the half. Now, do you know that the exponent 1/2 means the same as square root? Yes? And the square root of a number must be a positive answer. So it's good that 4 is a positive number, because at this step, if that number on the left was negative, we would write no solution. We wouldn't go any further. Okay, So I said don't write it with a radical sign. Keep it as an exponent. So how do I undo a 1/2? And the inverse of a fraction, in this sense, is the reciprocal. Can you tell me the reciprocal of that exponent? 2. So guess what I'm going to do to both sides? To the exponent 2. So how do I undo a fraction in the exponent? I do the reciprocal. How do I undo it? The reciprocal. And if it was a radical sign, I'd know the exponent that would undo the radical sign. You want me to say it again? Yeah. So if you have a fraction, how do I undo a fraction in the exponent? I do the reciprocal. Want me to say it again?
Wait, but can't you like turn it into like a radical?
Right, that'd be wasting a step. So it's better to know 2 ways to solve it rather than 1 way only, right? So I'm telling you, that if you have a fraction exponent, how do you undo it? Reciprocal. So let's say the exponent was 2/3. You go 3 over 2 and not waste the steps of trying to like write it as a radical. It's unnecessary. So again, the reciprocal, 2. So 4 squared is 16. Then I have just C subtract 12. Obviously add 12. And what's your answer? 28. If I go back to the beginning and I put in 28, does that actually work? So the left side is negative 36. 28 take away 12 is 16. The square root of 16 is 4. Does left side equal right side? 28 is a good answer. Let's try number 6. Davian, are you ready? What's step number 1? Yeah, and you identified the radical part, right? So what's outside of it? Subtract 11, right? So I have 7p, subtract 1, to the 1/3 is equal to what number? At this point, you should think. You should think, does this mean no solution? Because I have a radical equal to a negative number. Or is there a solution? There is one because it's an odd root, right? But if it was an even root, it'd be over. No solution, over. Yes? So how do I undo a fraction? Is I do the reciprocal. Can you do the reciprocal to both sides? So what's the reciprocal of 1/3? Davian? 3? And then on the right side, what do you think negative 4 to the exponent 3 is? Excellent. And then we can finish it, right? If we add 1, that's negative 63. Does 7 go into that evenly? Times tables, what do you think it is? Huh? Negative 9. And then, if we put that answer, negative 9, back in, does it solve the equation? So, negative 63, negative 1 is negative 64. The cube root of negative 64 is negative 4. And negative 4 plus 11. So, left side equals right side. When you isolate the radical, and it still works, like if you have an even radical and it's equal to 0 or a positive number, you can assure yourself that likely it is a good solution, not extraneous. All right, number 7. Let's look at it. Aaliyah, how would you solve number 7? So when you isolate the radical part, that's the 4th root of 8k plus 12, and when you add 9, you get negative 2, correct? At this point, Aaliyah, all I'm asking for you is that it should cause you to think, if you've isolated the radical part, and it's equal to a negative number, now what? Does this mean no solution, or can I go forward? Done. Right? So if you are aware of what's happening, an even root cannot have a negative answer, yes? So whether it would be a 2, a 4, a 6, an 8, whatever, Can you see why we stop there? You could do more work and check your answer and check that it's wrong, or be better and realize at this point there's no solution.
So if there's an even root and it's equal to a negative number, there's no solution.
You know what? You just said it perfectly. I think I said that. You're like my mini-me then. I can say it and you can then say it back again. How could that be? As a math person? 8. Let's try this. Chris! What would you do to solve this?
I would add
I'm listening.
I would subtract negative 18 on both sides.
So you just subtract 18, and what number would you get?
Right side get negative 20.
Good. What would you do next? What would you do next?
I would square the whole equation.
No. What would you do next?
That's 11 negative.
I would too. Negative 20 divided by negative 4 is? Chris? I didn't even hear your answer. Negative 20 divided by negative 4. 5. Now, only at this step should you think twice and make sure, can we go forward or should I stop? Right? Like it's when you isolate it, can you tell? Not beforehand, right? All the other negatives beforehand, it didn't matter until this point. So we can go forward? I agree. What would you do? So if you square both sides, it's now equal to 25. Then what would you do?
I would subtract the 43.
Excellent. Do it. 25 take away 43. I'll wait as long as it takes. 25 take away 43. Yes, negative 18. I heard that, right? And then what's the last step? And what do you get? Done. And you know what? We did the work to make sure we could go forward. So we know that the solution's a good solution. All right, turn the page. Hey, number 9. Do you see a radical equaling to another radical? So at this step, we can undo it by squaring both sides. It's important that the radicals are matching. They have the same index. You ready? All right. So we have u subtract 8 and 43 subtract 2u. So solve for u.
Sir, why did you swear them?
I like that. What? Even on my video, I want to know that you know my name. Mr. Hey, that's it. Thank you. So, I want to solve this equation by first undoing the square roots. So what undoes the square root? So I can remove it and then go on. The square removes the square root, right? We good? So now I can obviously solve this, right? Yes.
So we always have to go back, once we find u and plug it in.
So, in this situation, this is a special situation where when you solve it, what I have to be aware of is whatever answer I come up with, when I plug it back in, all I care about that it's not negative. So you could do the work correctly, but if you plug it back in and it gives you a negative number under the square root, no solution. So we do have to check for this situation. All right, can you combine like terms? Lizbeth, what would you do to combine like terms? How does the negative 2u and the u's, how do they go together? So what would you get? 3, and then you would add 8 and get 51. Do you know that 3 goes into 51 evenly? 17. Now, when I plug 17 in, this is what's important. 17 take away 8. Positive answer? Okay. 2 times 17, and then 43 take away that. Both, right? We can't have, even if they both were -3 and -3, that's bad. You can't have the square root of a negative number. It's imaginary. So that's a good solution, because when you plug it back in, it gives you a positive answer underneath. If you plugged it back in, and even though both would give you the same number, if that same number was negative under the square root, no solution. Number 10. Let's see where we're at. Hey, Dahlia, how do I solve number 10? So, do you notice the index is the same on both sides? How do I undo a fourth root? Is I do the exponent that goes with the index. So the power of 4 undoes the root 4. And all that leaves me with is what's underneath the radical signs, right? So 27 take away 2d and d take away 3. How would you combine like terms, Dahlia? So add 2d, that's 3, right? Add 3, and that's 30. So when you divide, the answer is 10. I need to make sure that when you plug 10 back in, is that a good answer? Or does it give you a negative number under the even root, right? And when you plug 10 back in, you get positive, right, on both sides. Number 11. Alyssa, what would be a good first step? Divide by 4. I like that. What would you do next after you divided both sides by 4? Now, we got to be careful here, because when we square, it also belongs to the 3. So on the left side, you have 3q plus 15. On the right side, what would you have?
19.
And that's where you might make a mistake, right? Is to not squaring the 3 to make sure. And then when you combine like terms,
You subtract 3q on both sides and get 15 plus 6q.
and when you divide, does 6 go into 15? I mean, you could reduce it down, right? So it's 5 halves. When you put in 5 halves, does that give me a positive number underneath the square root sign, right? And we're good. Number 12. Eduardo, what should I do first in number 12? So, not multiply, but raise both sides to the power of 3, right? To undo the radical part. So, cube root is undone by the cube. Yes? So, what are we left with on the left side, Eduardo? Left side.
14 minus 10.
And on the right side?
-8.
Perfect. And that -8 is kind of the hook, right, of the question. It should get easier now. Because it's an odd root, I don't need to check to see if it would be imaginary. Only even roots, right, have that possibility. So, Eduardo, what would you do next?
Add 10n to the left side.
And then divide. Oh, there's no n over here. And then when you divide, the answer is beautiful. All right, number 13 on is going to be a little different. So, Marilyn, what should I do for number 13? I want to know whether you can see why it's going to be a little different. So, the square root is already isolated, so I would square both sides. So, when I square both sides, I get 8x equals what? x squared. Now, we don't have a linear equation. All the other examples, we had a linear where we just combined like terms and solved it. This is a quadratic. Why do I know it's a quadratic? Yeah. So, how do I solve a quadratic? To solve a quadratic, you make it equal to 0 and factor. And if you can't factor, then you have other ways that are longer and uglier. But equal to 0, factor. So how would I make it equal to 0? Is I want to keep x squared positive, so I'm going to subtract 8x. Marilyn, do you know how to, I know you know, how do you factor x squared subtract 8x? I want to believe you that my hearing isn't going, but I feel I'm having a challenge hearing it. So tell me the factoring. So you factor an x out, what are you left with? Is that right? So one factor is x equal to 0. The other factor is x subtract 8 equal to 0. So I already have one answer. The other one add 8, and the other one is 8. I got to be careful here. There's a good chance for a quadratic that one may not work and one may work. So when I have a square root, when I plug it in, the square root of 8 times 0 equal to 0. Is that true? 8 times 0 and the square root of 0, that works, right? 0 is okay. Negatives, no. 0, good. How about 8? The square root of 8 times 8, does that equal 8? Do both work? Beautiful. Done. So, radical could end up in a quadratic equation where we have two answers where one could work and one may not work. All right, number 14. Corey, what would you do first?
I would subtract 7 both sides.
So let's subtract 7a, and then how many a's do you have on the right side? Now, the square root is isolated. How do I undo a square root?
You square both sides.
So I have 12 subtract a equals a squared. What type of equation is this now? So how do I solve a quadratic? Equal to
0.
factor, and then solve. And I got to check to make sure both answers work. So if I'm going to make it equal to 0, I'm going to add a and subtract 12. Yes? Is this factorable? Two numbers that multiply to negative 12 and add to 1? Is that factorable? There are two numbers that fit. What do you think?
Negative 4 and 3.
So positive 4 and... So why is it positive 4? Because they have to add up to positive 1, right? So positive 4 and negative 3. So when you solve this, what answer do you get? The first factor gives you the answer,
It would be negative 4.
negative 4. And the second factor gives you the answer, positive 3. Now we got to be careful. We got to understand if it's going to give me, if both work or if one's a bad answer. We can go back to here to make it a little easier. Do you remember we had a line 12 subtract a is equal to a? Like we had that line. What's wrong and why am I going to cross out negative 4? The square root of any number would never equal negative 4, right? So if you plugged in negative 4, we can't take the square root of, it'll end up being the square root of 16. Does that equal negative 4? No. How about 3? 12 take away 3?
Put a 9 in there.
And then the square root of 9? Does that work? So one answer is a good solution, yes? What name do we give the second one?
Shades.
So negative 4 didn't work, but positive 3. So how many solutions are there here? 1, and the only solution is 3. All right, number 15. Cristobal. You ready? What would you do first? That's okay. It's good I asked you then. What should I do first?
Root 6m minus 38.
What you notice is the square root is already isolated. So I can just square both sides. Is that right? So when I square both sides, squaring and square root undo each other, and I have 6m subtract 38. Yes? How about m subtract 5 squared? What's that?
M squared minus 45.
Minus what?
45.
Really? M. You think m subtract 5 squared is m squared subtract 25. Try again. You think it's plus 25? So I do think that negative 5 times negative 5 is plus 25. But I also think you're missing something. M subtract 5 times m subtract 5. Do you have to do this, or can you do it in your head? M subtract 5, m subtract 5. What am I missing? Negative 10m, right? Do you recognize when you have to FOIL? What type of equation is this? So I need to make it equal to 0, yes? So how do I bring 6m and negative 10m? How do I combine like terms there? So what's negative 10 subtract 6?
4. Negative 4.
Try again. Negative 10 subtract 6.
Oh, 16.
So negative 16. How about negative 38 and 25? What would I do?
Subtract 4.
Negative 38 and positive 25. What would you do?
Add 4.
Yes, add 38, right? 25 plus 38. I'll give you the first digit.
65. 63.
Yep, I'm scared, Christabel, but I believe in you. Two numbers that multiply to 63 and add to negative 16. Two numbers that multiply to 63.
7 and 9.
So 7 and 9, right? Do they both need to be negative?
Yes.
And they fit. So one is m subtract 7, the other is m subtract 9. So what are the two solutions here?
Positive 7 and positive 9.
Now, just because an answer is positive or negative doesn't mean you cross them out or keep them. You have to go back to the beginning. You ready, Cristobal? If I put 7 back in, you can do this in your head. 6 times 7,
49. Oh, wait, no. 42.
take away 38 is 4. And then the square root of 4 is 2. And 7 take away 5 is 2. 7 works. 9, 6 times 9. Yep, take away 38. That's 16, right? And the square root of 16 is 4. 9 take away 5 is 4. Do they both work, right? We have no extra solutions, yes? They both are good. Hey, they both could be good. One could be good. They both could be bad. You have to check them out, right? All right. Danielle, are you ready? What should I do first? So on the left side, what do I have? 2v plus 3. On the right side, v plus 2 squared. I know you're going to learn from Cristobal. How do I multiply that out? V plus 2 squared.
B squared equals 4b plus 4.
Excellent. Make it equal to? How do you combine like terms? Subtract 2v. And how many do you have? What would I do with the 3? And you get? Factor it. That means there's only one factor, one solution. Then what do I have to do with negative 1? Is I go back to the question and I make sure negative 1 gives me a good solution. Does negative 1 work? 2 times negative 1 plus 3? Negative 1 plus 2, it works, yes? So just because the answer is negative doesn't mean we throw it out. Or just because the answer is positive doesn't mean it can't work, right? We got to make sure it works or doesn't work. All right, number 17. Pedro, you ready?
Oh, alright.
What do I do first?
Do you square both sides?
And what are you left with when you square both sides?
5y minus 5y equals
551, I think you meant.
51 minus 5y equals y squared minus 22y plus 121.
Excellent. Do you see how when we square that, some of you might have to do this, right? To be able to multiply it out. But you got to be aware you are foiling, right? On the right side. All right, we're going to make it equal to.
0.
How do I do that?
So you add 5y to the right and now subtract 51.
That's one at a time. So add 5y, what do I get?
So minus 17y.
And then what do I do?
Then you subtract 51 on both
121 take away 51.
70.
Wow, that's good subtracting.
And then you use photo and then you get 1.
Factor, right? What are the two numbers that...
Y minus 7 and y minus 10.
So from each factor you have a 0.
Yes.
So what's the 0 for the first factor?
7 and then there's 10.
All right. Now, can you look back at the beginning? There is one solution that's good, and there's one solution that's bad. Can you see the solution I'm going to cross out? And why? What happens when I plug 7 in? What's 7 take away 11?
Negative number.
Can the square root of something equal negative 4? So 7 is an extra solution, yes? Extraneous? How about 10? What happens to 10? What's 10 take away 11?
Negative number.
What? There is no solution. Both answers lead to a negative number, right? The square root where the answer is negative, bad, bad. So what are the options? Both could be good, one could be good, or both could be bad, right? Any of those could happen. All right, last one, 18. Sarah, you ready? Let's do this. You got the good one. Step 1. I would square both sides. Now, the left side is easy, right? The right side, you just might want a box to foil it, right? That's root x subtract 1. That's root x subtract 1. Could you multiply that out? Root x times root x is negative 1 times that is negative root x. Negative times that is negative root. And negative times a negative is. So there are like terms in the diagonal. So how many negative root x's, right? That's negative 2 root x. And then 1. Now we're going to combine like terms. What happens when I subtract x to both sides? They eliminate, right? What happens when I subtract 1 to both sides? I get 8 is equal to negative 2 root x. What would you do next? Divide by negative 2? And what answer do you get when you divide by negative 2? Now, when you've isolated the square root, and it's equal to something, you should pause and think, can I go forward or is it over? Can the square root of a number ever equal a negative one? So the answer is no solution. All right. GMAT. Over and out.